So I've said before that Go suffers no fools. And one of the cool things about the Go programming language is that it's got the depth and the power to go as deep as you want to go. And as you grow, it's going to grow with you. And that's awesome. And this is a beginner to intermediate level course. And I've pointed you in the direction of Bill Kennedy for his intermediate to advanced course. And you could read his book, and you could even take his training online somewhere now. I'll try to find the link for you for that. But that's a great course to go deeper into the internals of the language and be able to optimize things. All of that said, to preface this video, where I'm just going to talk about a couple of notes. And if you're getting a little bit like lost with the details, last thing we went through the language specification, just sort of like, hey, let me introduce you and continue showing you the language which is used to talk about this language, the people who created the language, how they talk about it in the language specification. I want you to become comfortable and familiar with that. But what I don't want is for you to feel like you're getting lost in the weeds. So this stuff is just kind of nice to know stuff. And I just wanted to reflect on it. It's in my notes, and I thought it's good to talk about it. And I said we would talk about OOP and his Go and OOP language. But first, I just want to say, man, the main thing, the main takeaway, and this is going to be a little bit of a review before we jump into, talking about these notes and OOP and all that, is you want to create a variable, if you want to create a variable X of type int, you do that. And if you want to create your own type, you can do that, type person, struct, right? And so notice just the similarities there, in what we're doing. And let me just type that out so I could finish typing and start talking again. But we have variable X of type int. Go's three goals, the language's three goals in creating the Go programming language was efficient compilation, efficient execution, and ease. Ease of programming. Like, that's nice, that's clean, that's cut down to its essence. Variable X is of type int. The type, we're a statically typed language here. It's type int. Create our own types. Type person, the underlying type is a struct. And then we have our fields here, right? And so the identifier and the type, we have our fields. And if we wanted to, we could do things really goofy like this. Type foo as underlying type is an int. And then we could create var y is of type foo, right? This is not a good practice. This is known as aliasing a type. The only way you'd want to alias a type was like if you wanted to attach methods to it. And we're going to learn about methods soon. So part of starting to talk about this stuff, you can't talk about one without talking about the other in some ways. Like I got to tell you about structs before I tell you about methods. Or I tell you about methods, then you got to know about structs. So you got to talk about one of them first because they go together. So the main thing for you to take away, is one, ease of programming. We got var x int, type person struct. Do you see the pattern there? Var and type, if we go to the language specification, Golang spec, and we go open up the language specification and we go down to keywords, right? We have here, we have var, we have type, right? We have var and type, and that's what we're using right here. These are the first ones, var and type. And then we have some identifier, and then we have this other one, int. Struct. Well, let's create a variable. Let's create a type. We create, and let me type this out, we create values of a certain type that are stored in variables, which can only hold values of a certain type. And those variables have identifiers. Right? So just being clear and precise with our language when we talk about things. This is a variable, it's an identifier, and it holds values of type int. But just look at that parallel and those similarities. Var, type, identifier, and then what's happening? Like the underlying type is a struct. The underlying type here, the concrete type, is an int. Right? So that's kind of cool. All right. So that's the first thing, is I don't want you to feel like you're getting lost in the weeds. I'm just going to copy this code and throw it over into our outline so that we have it, because it's here in housekeeping. I wanted to go through a few notes that I've got here and talk a little bit about OOP and similarities. And we're doing this maybe, before methods, but we'll get to that. So there's that chunk of code. And I want you to see that right here, we could create a person, P1, colon equal, person, and then curly braces. And this is the composite literal, which we've been working with through this whole course. The type, the curly braces, and then the values. And you will see people do it like this in the wild. I do not, James Bond, I do not want you to do it like that. I always want you to use the field names. And so the field name is like this and like that. And the reason I want you to do that is because it's clear. You should write code that's clear and readable, that other people can look at and understand what's going on. And so you want to write enough, but not too much. Enough, but not too much. So there's that code. So that's the thing I want you to take away here. Don't get lost in the weeds. This is a composite type. We're composing together values that will be of different types. We could have different types in there. And it's a struct. It's a data structure, which is why we call it a struct. And we create our own type. And then we could create a value of that type and store it in a variable. Cool. If we wanted to, we could even make it anonymous. Take this right here and put it right there. So that would make it anonymous. So don't get lost in the weeds. It's simple. Just creating structs that hold fields which store values of different types. So let's just read through these notes here, this housekeeping stuff. It's all about type. Is Go an object-oriented language? So I'm going to click on this, and it's going to take me to the FAQ for the Go programming language. I'll bring this down and zoom in on it. And you could pause this video right now and read through that. Because this is how the people who created the language talked about it. So go ahead and pause the video and read through that. Cool. Did you do it? Nice. Yes and no. Although Go has types and methods and allows an object-oriented style of programming, there is no type hierarchy. The concept of interface in Go provides a different approach that we believe is easy to use and in some ways more general. There are also ways to embed types and other types to provide something analogous but not identical to subclassing. Moreover, methods in Go are more general than in C++ or Java. They can be defined for any sort of data, even built-in types, such as plain unboxed integers. They are not restricted to structs, classes. Also, the lack of type hierarchy makes objects in Go feel much more lightweight than languages such as C++ or Java. So that's pretty cool. And we'll see this in action more as we play around with it. And these are my words. Go has OOP aspects, but it's all about type. We create types in Go, user-defined types. We can then have values of that type. We can assign values of a user-defined type to variables. Anecdote, this makes me think of that song, It's All About the Bass, all about the bass. Except I hear it's all about the type, all about the type. And that's where at the beginning of this course I said, hey, Bill Kennedy says type is life. People used to say Go is all about type. I used to be like, I don't know what you're talking about. Now I do, and hopefully you're seeing that too. Go is all about type. So Go is object-oriented. It's got encapsulation, right? So we could create a struct like, type person struct, and it could have state, those fields. It could have behavior. We could attach methods to it, and we could have exported and unexported or viewable and not viewable aspects of our code from within packages. We have reusability, we have inheritance with embedded types, so we can embed a type and one other type. We have polymorphism with interfaces, and we have overriding and with promotion, intertype promotion. Traditional OOP, we have classes. It's a data structure describing a type of object. You can then create instances objects from that class blueprint. Classes hold both state, data, fields. So state and data and fields are all kind of the same way to talk about what we've seen as fields in Go. And then we have behavior and methods, and behavior and methods could be used interchangeably when you talk about OOP in classes. And in OOP, we talk public, private. We don't talk public, private in Go. We talk exported and unexported, viewable and not viewable. And we'll see that coming up here when we start working with packages. And maybe we'll do a little marshalling and unmarshalling to and from JSON so you could see that. And then we also have inheritance in traditional OOP. In Go, you don't create classes, you create a type. You don't instantiate, you create a value of a type. User-defined types. We can declare a new type. We saw that foo, right, in that code. I think I already got rid of it. I did. Boom, boom, gone, gone. Let's see if I put it right here. Is that the code I put right here? Yeah, cool. So here we have type foo int, and then a variable y is of type foo. And we could say, well, y is equal to 42. And then we could use conversion and convert that to an int if we wanted, right? And so that's just ridiculous code put together simply to show a point. Type int as type foo in assignment. Cannot use int 42. So I need 42. And now I could do this. Run it. And now if we look at the type, printf %t, that type is foo, but we could convert that to an int if we wanted and run it. And that's because the 42 is indeterminate, and so I couldn't convert it yet. It wanted to figure out, the compiler wanted to figure out what type it was first. And so there's an indeterminate type in Go where it's like something, constants can be a constant of a kind, or it could be, you know, declared constant where you're like the constant is of this type. So again, if we have that keyword constant, and then we have bar and we have int, you know, is equal to 42, and now we could print out bar here. Let's put a couple of new lines in, just break it up. Cool, so that constant, and again notice, you know, type, var, const, and if we go to the language specification, which I think I have open somewhere, frequently asked questions, Go playground, I do not, Go programming, cool. Constant, and then here's constant, another key word. So notice that parallel again, type, var, con, right, and then some identifier, some identifier, some identifier, and then we could specify the type, in which case this type is already known and the compiler doesn't have flexibility, but, and this gets more into the intermediate to advanced area, but if we don't specify the type, we could also do it like that, format it and run it. It'll figure out the type when it runs, and so that gives us flexibility. So I could actually probably do this, because it's type int, let's see what, its type is indeterminate, it will probably assign to here because that is type foo. And that assigned, right? That assigned right there. And if I look at this right here, take away that conversion and run it, right? It is still, it took this, and that wasn't determined yet. So that's a constant of a kind. The type wasn't determined yet and said, okay, 42, yeah, you could be a type foo. You could be type foo, because that's what y wants. Var y is of type foo. And we could take this, which isn't determined. But if I do int here, it's no longer a constant of a kind, right? It is, it's really clearly defined of this type. And so when I run this, it can't use type int. And so there's that kind of parallel type system when you get into the constants, which is interesting. Just a little anecdote. But you wouldn't want to, I brought up that code because we were looking at aliasing a type, var y foo, really. And foo is kind of a type alias for int, and that's not a good practice. But that's just an illustration of how we could create our own types, even of type int, underlying type int in Go. So type aliases aren't good practice, though sometimes you'll see that being used. Like type duration in the time package from the standard library is an int64. Type duration from the time package is int64. So one thing I've also been wanting to point out to you is if you go to golang.org and go to documents, and then go to package documentation, you might be wondering, well, how do you know about all the different packages that are in the standard library? Here they are. And we've looked at the fumped package right here and saw fumped for printing, you know, basic input-output printing, and I/O functions analogous to C's printf and scanf. But there's a lot of other packages in here, like encoding JSON. We might take a look at encoding JSON. Or down here, if we look at, let's see, net HTTP allows us to do web stuff. So a really powerful standard library with a lot of built-in packages, which you could draw upon, crypto packages. You could draw upon all this to do stuff, buff.io packages. archive to tar to zip packages. So some pretty neat stuff. All right, so that's just a little bit of housekeeping, a little bit of talking about OOP and thinking about, is Go an OOP language. We've seen a struct, and we've seen how we could bring together different data types in a struct. And that's why I said at the beginning of this video, I don't want you getting lost in the weeds. Just sort of want to reflect upon a couple of things, which we just did. And the last couple of ones I had down here, which I haven't put up in the list yet, name types versus anonymous types. See, anonymous types are indeterminate. They have not yet been declared as a type. They have not been declared as a type yet. The compiler has flexibility with anonymous types, like constants of a kind. You can assign an anonymous type to a variable declared as a certain type. And you saw me do that where I had that constant of a kind, and it was just 42. And then I assigned that to something which was type foo, which the underlying type was int. And the assignment can occur. The compiler will figure it out. The compiler will do an implicit conversion. You cannot assign a named type to a different name type, right? So if I had that constant where the type was int, I couldn't do that. And then padding and architectural alignment, just to make a note about that. The convention is to logically organize your fields together. Readability and clarity trump performance as a design concern. Go will be performant. Go for readability first. However, if you're in a situation where you need to prioritize performance, lay the fields out from largest to smallest, e.g. N64, N64, float 32 bool, largest to smallest in your struct. And that's going to give better architectural alignment, meaning when the compiler builds for a certain architecture, it's going to be able to use less memory if your fields in a struct are laid out from largest to smallest. But don't prioritize laying out your fields from largest to smallest. Prioritize readability. So go first name, last name, age. Like that's more readable than age, last, license to kill bool, first. That's like the fields are all over the place. Go for readability first because Go is already performant. But if you really need to micro-optimize, you could do this architectural alignment. And again, that's a more intermediate to advanced topic, but I thought I'd just make a note about it because there is that consideration when building structs. And you could actually see, if you take Bill Kennedy's class, keep talking about him, that he'll show you how you could actually see what's happening as you build that stuff and print out the memory and how much is being used and all that. It's pretty cool. All right, so those are just a few housekeeping notes. And these are just sort of like, things which are interesting to ramble about and questions. Hopefully they answered a few questions you might have had. And if it didn't, hopefully it gave you a little bit of insight. But what I hope it didn't do was just raise more questions for you and make you feel confused, because that's not the intent. This is just purely FYI. To use this language, it's really about ease of programming. All you got to do is be able to create a struct. You don't have to jump into the internals. Man, the people who built this language, they did a great job. They did a good job. You don't have to worry about it, right? Like use it. And then as you use it more, you'll learn more. Then use it a little bit, to a higher performant level. But right out of the gate, it's going to be super performant and you'll be happy with it. You don't have to know those intermediate to advanced things. I'm just starting to sort of prepare your mind, give you a little introduction to them. So as you come across them, you'll have a little bit of exposure and a little bit of understanding what's going on. All right, so I'm going to drop these last notes in right here, these last housekeeping notes, and I will see you in the next video.